So it's funny, this was a really funny joke a few months ago, but it seems like every conference has a talk like using State of Stateful now. So I actually did submit this talk to a few conferences, didn't get accepted, so I'm glad I get to like take this current information and condense it down into about 30 minutes. I think there's many of these topics where you could talk for an hour about things like Stateful Sets, if you've been using them for since they came out a year ago. So greetings. My name is Grant. I work for a company called Humio. This is our adorable swag, the owl. And what we do is we make a log aggregation platform similar to a Splunk or an Elasticsearch. We allow you to log everything and answer anything. Sorry, I have to make sure I always get that right on the marketing end of things, because I missed it when at DevOps Day Seattle. So got it this time. So what I do at Humio, I'm an engineer. I'm leading our infrastructure efforts. Previous to this, been in a lot of interesting companies. ITA Software, where I learned a love for functional programming, and Lisp, and Boston. Basho, who made React, the key value store built on Erlang. And then for the last 3 years previous to Humio, this January, I worked at Vevo, where we were early adopters of Kubernetes. So these are things that I've been working on for 3 years and I'm very passionate about, and I'm very passionate about Kubernetes, and the FUD kind of annoys me these days, I'm not gonna lie. But that's a story for another day. So what are we gonna talk about today? We're going to talk about what stateful systems are and why stateful systems are important. What are the Kubernetes components that make these things up? Yes, I'm gonna show you a deployment of WordPress, and there's lots of reasons why I'm gonna talk about that. And then I'm gonna show a Kafka deployment based on the current Confluent Helm charts, which I think are really solid. There's another half that story around operators and CRDs that isn't quite there yet, but I think it shows a lot of promise in terms of deploying distributed systems. And then I'm going to talk about this really interesting thing we did at Vevo around, so I guess this was, the fall of 2016? No, it was 2017? I don't know. But we built a distributed video encoding system, and I'll go into a lot of interesting details. And if you've worked in video and live video encoding, I think it's a really interesting approach. So why stateful systems? What is a stateful system? I'm sure everyone here knows, but it's one that stores state. So just think about putting a database or something that relies on something being around when that computer comes back up to work. So we live in a stateful world. I can't imagine any of you work in an environment where there isn't a stateful system, be it a RDBMS, or Mongo, Elastic, insert your stateful system here. Common infrastructure is easier to maintain, and Vevo really taught me this. When we got off ECS and we got off Elastic Beanstalk and really consolidated on Kubernetes, we had much better engineering velocity because everyone was shipping using the same libraries, same approaches. There weren't all these one-offs. Luckily, we had a CTO who really bought into that plan as well and basically forced consolidation across the engineering org. It was really powerful. There's better cost optimization when I'm only having to worry about a certain type of classes system, be it on GCP with an N-standard 3216 or EC2 with M4s, Rs, C5s, whatever. Because I can buy more, reserve systems. Elasticity, I think, is something that people in stateful systems aren't used to, but I think that if you tailor your database to run in distributed systems, you can get really powerful things out of the elasticity, being able to scale certain parts of your database independently. And this is something that we're working on at Humio, and something I'm really passionate about. And Kubernetes is going beyond cloud environments. I think with the recent AWS announcements and with the recent GCP announcements, we know that they're working on hybrid cloud. So there's going to be a lot more people running Kubernetes in the data center and in the cloud, and being able to deploy one way for each of those environments is really powerful. So what are some of the challenges? I still feel like Kubernetes is a microservices native first platform, and it feels that way. But I think that over the last year, especially with the advent of stateful sets, that's becoming less and less so. State and ephemerality are a challenge. Host identity is a challenge. So using IPs to make all your pods talk to each other in distributed systems is a bad idea, especially if you use preemptible nodes like I do because it's cheaper on GCP. It generally is requiring network block storage, or this is going to vary by provider, but you're generally going to have that piece, and that piece can be an EFS, EBS, GCP disk, whatever. And there's really complex orchestration requirements, and we'll talk about that a little bit later. Stateful pods are generally a much bigger footprint. When I run Humio in a Kubernetes cluster, I'm giving it 64 gigs of RAM. My Kubernetes cluster looks way different than yours when I'm running my database that's pumping in many tens of terabytes a day. And that's just, I'm willing to accept that trade-off because it's easier for me to manage even in a Kubernetes cluster when a worker node's maybe running 1 or 2 pods, things like that. So there's performance impacts and trade-offs. Once again, I think this is about the flexibility I get in running my system. I'm willing to take that 10%, 5 to 10% trade-off. Multi-cloud is definitely, if I'm deploying on GKE versus Amazon setup or Azure setup, there are slight differences, but most of those are built around storage classes right now and persistent volumes. These things are much easier to do from scratch. If you've been running Kubernetes for 2 or 3 years, you probably bootstrap a lot of your resources with Terraform or insert whatever you use there, and then you're handing that resource ID to your Kubernetes template to mount this volume and things like that. So we all built these different systems that are now native to Kubernetes, particularly around persistent volume provisioning and things like that. So why shouldn't I do this? It's because there's not out-of-the-box magic. I'm not going to tell you I'm going to solve your Kafka problems today. I can tell you how you can maybe get there. But your Kafka environment, I'm sure, is pretty unique. And that's something I've learned a lot about at Humio. It's slow. It's hard to debug. Starting a cluster that depends on an ordered rollout and you're rolling out 30 nodes can take 20, 30 minutes. So it's hard, like the feedback loop is hard when you're debugging this. There's lots of easier alternatives. If you're using Amazon, RDS is a really good alternative to running your own stateful system in Kubernetes. And because you're going to spend way less time, overhead, and people managing that system if you make Amazon do it, especially for Elasticsearch. So losing data is easy. It's really easy to screw these things up, especially when you're developing and doing a production system that's throwing around tens of terabytes in Kafka is a scary proposition unless you know how to run Kafka. So you need to know these systems before you try to run them. Many of your database deployments are probably pretty bespoke. You may have some weird proxy or some weird like sharding concern or things like that, because that's how people live scaled. So it's harder to do that in the stateful systems. And then there's just management concerns. It's different. I want to say you should manage it the same, but it is different at the end of the day. So what are the parts to deploying a stateful system on Kubernetes? So you can do with daemon sets. So this is just going to take your pods and say on every pod I need to run X database. etcd is a good way you can deploy this. So it's really good for small environments that you're not worried about being elastic. And this is how many people, I think, did stateful systems in the past. But I think that in general, like daemon sets are more built for things like core services, like a Fluentd or a DNS. So it's good. It's definitely still usable. But you're generally going to be using local disk, and depending on your environment, those might be ephemeral. So and then you're mounting EBS into your daemon sets, and you just made your daemon sets more complex. So stateful sets have been a big change, I think, and you see a lot of people developing for them, be they CockroachDB, Confluent, et cetera. I am too. So this was introduced in December of 2017. It's formerly called pet sets, which are kind of sucky. And the real focus is around like ordinal deployment. So when I deploy these nodes, they're going to be in a fixed state, so 0, 1 through 10, for instance. And they're going to roll out that way depending on how if I do it parallel or if I do it in an ordered ready fashion where all the nodes are starting up. But I'm going to end up with pod 0 through pod 10 at the end of the day. And generally you're mapping these to a persistent volume controller, which we'll talk about in a little bit. And wow, if you're at KubeCon in December, it seemed like a quarter of the talks were about stateful sets, and the cockroach talk that I saw was really, really good around doing this as well. So I think we're just now getting to where people are comfortable doing this, and you're going to see real production deployments at pretty large scale in the next few years. So a little bit about persistent volume, PVs and persistent volume claims. PVs are your block storage, PVCs connect these persistent volumes to your containers. In the past, we generally would do what I would call manual provisioning. So I was running a Terraform to provision a disk and hand that resource ID. Things have come a long way in the last 2 years around that. So it's I don't need to have like set up a PV beforehand with EBS unless I want to rate it or something like that, or GCP. All those provisioners are built in, and then I know NetApp's doing something with ONTAP. no matter what storage class you want to use and storage backend you want to do, things are getting easier and more dynamic. There's many different approaches underneath. And so this is really a choose your own adventure. And so I think if you've been running Kubernetes for a long time in production, you probably already have something for this, or you already have an approach that's inherent in your environment. So it's difficult to change that out because you're gonna have to worry about tagging and all these crazy things. So maybe you don't want to change your setup. That's fine. I think it's pretty easy to do with Kubernetes. The next part of this is services. So this is how we communicate with the application. So if you're running an internal service, you're doing it with cluster IPs and hitting that cluster IP, which load balances to the rest of your nodes. When you're running a distributed system that requires all the nodes having like a host name about all each other, this is where headless services come in. There's kind of two facets to this, but the most important one to me, at least when I'm deploying my setup, which is fairly naive, is that I need all the host names. So I need to be able to associate a DNS like entry with an individual pod, and so headless services give you this ability, as well as a few other ones like that are cluster IP. Then there's load balancers. This has come a long way as well in the last few years in terms of when I'm deploying my Kubernetes service, I say I need a load balancer, and it goes and starts an ELB or what do they call them, forwarding? I always forget what they call them in Google. I guess a global forwarding rule or whatever. And then there's node ports, which is actually something I use a lot of because certain load balancers don't scale quite as much as you want them to, and you want to shove 20 terabytes through a Google load balancer or an ELB. It takes a while to scale, so I just use node ports and hit all the nodes directly for some of my more brutal scaling tests. Last part, I'm going to talk about in detail, and there's all these other things. I'm not going to talk about pods. I'm not going to talk about storage classes. Our operators and CRDs, and these are kind of the I guess the dark magic of where things are at today. And there's lots of people that say they're going to come out with operators. Looking at you, Confluent. And they're not quite there yet. You can get a pre-release, and not everyone has it. And I'm really curious how this is going to come out because I don't think there's a lot of solid examples around. There's some tries at doing like Kafka operators, but they're not. I'm a little hesitant to run them on my production Kafka cluster right now. So those are operators, and there's custom resource definitions which allow you to set up kubectl get Kafka, and it will tell me about my Kafka. So I'm setting up these REST resources that I can interact with that can run my operators and things like that. Really, at the end of the day, it's about being able to scale up and down your stateful sets and orchestrate that well, move topics around, move partitions around, et cetera. And then, things like backups as well. So now I'm going to talk about WordPress and why. I had this challenge at Vevo, which was essentially, we had this marketing department, and they wanted to use WordPress, and no one wanted to touch the WordPress. So we deployed, what did we do? I guess we did maybe it was an Elastic Beanstalk setup, or we just did an ELB, and there was this node, and then George Michael died. And Vevo does music videos, so I'll be a little bit cynical here and say that marketing at Vevo took advantage of major stars' deaths because their video views went up. And so they posted this really touching, amazing blog entry about George Michael dying and the impact he had on music. And I loved it. It was great. And then our WordPress site went down because it was like an ELB into really tiny nodes. And so I was like, screw it. We need to run this. Don't tell me that you don't want to run a PHP app in your Kubernetes cluster. As an infrastructure person, you shouldn't care because it's Docker, and if you can make PHP work, that's what you should do. So I made people on my team do it, and they didn't want to do it, and they didn't listen to me the first time, and they didn't use EFS, and it was even bigger mess. But eventually we got there, and so this isn't quite the approach that we took initially. I think we used maybe pet sets or whatever, and then eventually, right now, all it is just a deployment. And Joseph runs that group now from Vevo. If you're looking for an infrastructure job, he would want to talk to you, especially if you know Kubernetes. He's looking for people here and anywhere remote. Shout out to Vevo. And so, you can really do this just with the deployment, and you can do it with NFS because the hard thing about WordPress is the way people manage it. I need this stateful disk that's handling people's uploads and handling their stupid plugins and all these things. So at the end of the day, you build a Docker container that has all the crap you need in it, and then you let people go wild and you just store the state on EFS. And because it's really, on EFS and Amazon or NFS, insert your NFS here, everything's fine as long as you use a CDN and cache. Don't let things hit your WordPress directly. You're just looking for trouble. And then, MySQL, you can do it like in an RDS, or you can run it yourself. So what does this look like? So this is it. Like we have an ELB. It's a load balancer. I'm going to use my cool little trick here. Woo. So that's where the service comes in. And then the next part of this is we have a deployment. And that deployment has a PVC, and that PVC is an NFS somewhere, be it an NFS or whatever. It's just a resource. These things are really, really simple. And this is all it takes to make a scalable, essentially WordPress solution. Anyway, so this is essentially the YAML to do this. And the important parts, it's really not all that interesting. I just have 3 replicas, and those replicas have a volume mount. And if you don't have a lot of data or a lot of, if you're not running a web scale database, you can do EFS, and it's totally acceptable in my book. So if we wanted to do the MySQL part and not actually use RDS or use, I guess there's serverless serverless databases now. You could use those too if your WordPress site gets 5 hits a day. So it's totally feasible to do that as well. So if I wanted to deploy this as a MySQL stateful set, I'm going to have a service that's load balancing my requests. And then I'm going to have this same deployment. I'm going to have the same PVC. And then my MySQL is going to need to be a stateful set if I'm wanting to do a primary pod, a primary and a secondary. And then those are going to be attached to these individual things right here, the PVCs and the PVs. Now, I think the challenge here though is that when you actually look at what the YAML looks like, and the challenge in this is where things get more complex, and this is why I'd maybe suggest you consider using a thing like an RDS, because I have this headless service. We've talked about that. That's pretty easy. And then I have the server just down here, which is a cluster IP, so every pod can just hit the DNS to hit this. But this is where things get hard, because what I need to do in order to make this kind of primary secondary setup work up is I now need init containers. I need containers that run before my containers to bootstrap a config, to store in a config map, or what have you. So I just really, really upped my complexity in this setup because I have an init container, and then I wanted to point out the ordinal index here. So what I'm actually, what this code is actually doing in this code, oh no, keep hitting the wrong button. What this code is actually doing is essentially going through and looking at the ordinal index. So is my pod, MySQL 0? And if it is, then it's a master. If it's MySQL greater than that, then it's a slave. Sorry, it's a secondary. And when that thing is a secondary, it needs to decide, when the next init container comes up, okay, if I'm master, then I do this. If I'm a secondary, then I need to bootstrap my data off some other server and build this thing up. So if I have a MySQL setup that is servicing, hundreds, thousands, of requests a day, do I really want to go through this ops headache to manage this, or do I kick it to my provider? That's up to you as the user. Now, maybe you have some cost-effective reason to do this, and it's not much a big deal for you to manage this, but I think this is one of those major trade-offs. And then we can actually talk about the individual pods themselves and the volume mounts and how that works. If you've been doing these systems, it's pretty straightforward in terms of how these things work. And I'm also running out of time. I only have 7 minutes left. So that's what a MySQL would look like. Here's what a Kafka cluster looks like. So what are the various parts of this? And this is basically straight out of, if you take the CP, the Confluent platform Helm charts and set up a 5 worker nodes. And a Kubernetes cluster. I use GKA for this. This is actually, I got the YAML out of our running cluster. So what are the parts of this? I have 2 stateful sets. I have a stateful set of Zookeeper pods, and I have a stateful set of Kafka pods. And then the way that the Kafka pods talk to this Zookeeper is I essentially just have one URL that one host name that I talk to for Zookeeper Connect, and everything bootstraps. The only important thing when all of this comes up is that these Zookeeper pods have the right MyID. If you've worked with Zookeeper, you know about this. So I need 1, 2, 3, 4, 5. And then when the Kafka pods come up, I just need a unique broker name. And that's really it. These things are actually pretty simple. These are just services. So these are load balancer services, although arguably this is a weird setup that I don't know why you would want to talk to your Kafka directly through a load balancer, but that's because of Kafka stuff. But and this is a really actually simpler setup than the MySQL setup. And a few things that I'll point out in particular are the pod management, the pod management policies. If you're deploying something that relies on things talking to each other in a good way, you want to use ordered ready. Otherwise, you can use parallel and start up 30 pods at the same time, but that generally leads to race conditions you don't know about that I found out in our own system. And then so this is the pod management policy, and then this is a fun one. If you're deploying headless services, make sure your service name matches the headless service name. Otherwise, you don't get DNS for your individual pods. Learned that one last week. And then there's things like pod affinity. So when I'm rolling out, when I'm actually doing a deploy, like during scheduler, ignore during execution. So if I'm actually doing a rolling update or a deploy, I'm willing to deal with Zookeeper pods being on the same node. Otherwise, don't put them on the same node. More Zookeeper YAML, and this is just the volume claim stuff. This is all you need to run a Zookeeper and mount a persistent volume. It's really, really simple now. And then here's what the Kafka set, stateful set looks like, which is pretty much the same thing. There's really not anything different here. It's the same parts. The only really interesting part is I'm surprised that they choose to do this. So there's a lot of weird bootstrapping that goes on exactly in the when you're running the container and then handing it to a Docker run. So that means that the Docker run is magic. And so when you encounter problems with this, you may need to look there. So finally, I'm going to talk about Vevo Live, which I like to call a stateful distributed system. So what was Vevo Live before Vevo decided to exit the consumer market? Vevo Live gave the weekend the ability to go live with his fans and have a chat. And they could vote on videos and play those videos, and we would do those things in picture-in-picture. We ran all of this in Kubernetes. So this was one of the most fun things I worked on at Vevo Live. It really involved all parts of engineering, and backend services, and infrastructure. And this dream was for any artist to take out their iPhone and go live on Vevo, and we would record them like Twitch. And then they could select any video on Vevo and make it picture-in-picture and switch it back and forth. We did volume leveling. It was really, really neat. So that was the dream. Why we chose Kubernetes is because 90% of our services ran in Kubernetes at the time. So we were going to make this distributed stateful system work. And what was the result? This is what we built. I don't know if you know much about how HLS or streaming video works, RTMP, but I'll just step through what happens when the weekend wants to go live. So he's basically going to talk to a controller, and that controller is going to say, reserve a set of pods for me. And this pod, this reservation is an ELB and a pod running 3 containers that all talk to each other. The reason why we had to reserve them, we had to create this whole system because when someone wants to go live, we couldn't wait 5 minutes for the artist to go live. It needed to be immediate. So we had basically bootstrapped 20 of these encoding pods before anyone went live. So when they went live, they were actually live. And then that RTMP stream came out, and it came into a muxer as the weekend selected videos out of the Vevo catalog. We then would do picture-in-picture in this muxer system, which is really just FFmpeg. That's what everyone uses. I'm not kidding. Just to put this in perspective, out of all of these things, this is just FFmpeg, this is just FFmpeg, this is just FFmpeg. And they're just passing around. And then as it came in, we broke Facebook's terms of service and streamed RTMP out to YouTube and Twitter and Facebook as well. So when someone went live on Vevo, we took all of that, muxed it together, and sent it to all their social media channels. So this is a really powerful thing for artists. And then if you know a little bit about how HLS works, it's essentially a reference to, it's an index URL that has a bunch of different variable encodings you can go through linearly, but we just ended up storing this stuff on EFS down here. So the output was EFS, and then that EFS was being read through by a bunch of Nginx pods behind Fastly and behind CloudFront. So the total time it took for it to go to here was 9 seconds. Okay, that's actually pretty good for live video encoding, especially when we're dealing with all this other stuff. Then there are all these other systems we built in Kubernetes. So the artist controller, he would do reservations, or he could kick people out of the channel, or she could do various things like end the chat, start the chat, answer questions. We had a question interface, and then there was this chat system, and then that's how it all went out. But I think this is a really unique approach that was pretty early, and I can show the code for this. We did, they don't run the product, and I got their permission to talk about this in such great detail. But it shows the power of what you can do when you put all these things together. Tips. I'm sorry, I'm running into the other person's time. I got a minute. So don't use IPs, use host names. You're just going to burn yourself. This is not going to fix your orchestration problems. If you have a big Kafka cluster and you have to toss around topics, you're going to need to write your own, orchestration, your own operators in order to probably handle your complex Kafka problems, or your complex MySQL read problems, or sharding, or whatever. Remember that node selectors and pod affinity and pod disruption exist. I would recommend, I guess I say this later, but maybe you run that big stateful system in one Kubernetes cluster, and it's just easy to manage because you manage, oh God, I did it again, because you manage other Kubernetes clusters. Consider changing or designing your application to work with stateful sets. So just be, if you had to write Kafka from the beginning to run, in today's systems, I think they design it a little bit differently, even though they're Java people. Sorry. So consider changing your application. That's something that I'm doing today. How can we make Humio work best in a stateful set in a Kubernetes cluster? What parts of our system do we need to break apart so I can scale them independently? These are all really interesting topics. So remember that replication factors can save you. If you're running a distributed database and you have 5 copies of that in 5 different availability zones, and one of them goes down, you still have 4 copies left. So maybe it's worth taking that database overhead, that storage overhead, and losing a node, replacing it, and moving the data over, or restoring from a snapshot or something like that. There's all these different things we can do to make these systems more reliable at scale. So avoid, I think it's general, I don't know if it's common mostly, but I think a lot of people are moving away from really large clusters doing everything, or maybe to smaller clusters in different cases and making those work together. Approach this like you would any other major infrastructure thing. Just because I'm running my Postgres and the master and the replica in the Kubernetes cluster, doesn't mean I need to treat it differently. I need to treat these systems the same. NFS isn't as bad as people say, but if you're using it on Amazon and EFS, just overpay for a terabyte in size. It'll be way faster. Write and read, because they actually, anyway, if you know how they cost out, you can eat up all your all your credits and then not have any more credits. So just get a terabyte and be happy. Snapshots are a valuable asset. Bake those in and test things. YOLO chaos engineering, kill those nodes. Maybe I don't know of any of the chaos engineering products, at least, that are quite tailored for doing things that I would want to do them. But I need to check them out because it would be nice. What's going to be the future of stateful? Block storage improvements. I think there are a lot of vendors like an EMC or a NetApp that are bringing things to the table that the enterprise cats had it really good for a long time in a lot of ways. SANs are pretty fast, y'all. So we're starting to see that bleed into how we run clouds now. I talked about earlier, hybrid clouds are more important. Multi-region. I think we're going to have multi-region cloud operators where I can run, essentially what Amazon gives you with RDS, with multi-region read capability or secondaries. It's going to be easier to get a more off-the-shelf installation. I think Cockroach is really setting the tone for a lot of these approaches. There's going to be more persistent volume options. There's Portworx, there's Rook, there's choose your own adventure on that. And then improved CRDs and operator tools and examples, because I think that we're still really early in that. So things to take home. This is just one part of your Kubernetes infrastructure. The other stuff, arguably, that you're already running is the core of your business and what Kubernetes really excels at. But over the last few years with developments like Knative and Stateful Sets, there's a lot more territory for running stateful systems. I encourage you to try this. If you Google about it, a lot of people say don't do it. I disagree. But start small, and this might not be right for you. So thanks for having me. I'm Grant. So KubeCon's next week in Barcelona. I will be there. So please stop by the Humio booth. We're going to be talking about a lot of interesting things. We're going to be talking about some of the things that I've been doing on Kubernetes. If you Google it, you might be able to find the marketing stuff on that now. I wasn't supposed to talk about it, but then they put it on marketing things. So go check out our marketing stuff. We'll have more owls at that conference, and try to bring more owls next time as well. And then I have a bunch of notes, so I'll post these a little bit later. And I was amazed at just, man, the Kubernetes docs have come a long way. Like when you deal like running stateful applications, there's actually a lot there for you to work with, although, and to work with. And then I have some other things that are detractors too that say don't do this. So check out the notes as well, and thank you very much for having me.